Hey, AB Chemisters, this is Mrs. Vandelay returning with this next section of the blank wall. So we're in this unit of like atoms and compounds. We are in the section of ionic compounds. What I would do at this point is make sure you get out your periodic table because you're going to need it to determine charges. So what is an ionic compound? An ionic compound is composed of two charged particles. Your typically metal ion or cation, we talked about that in chapter 2, and your non-metal ion, which is an anion, or your polyatomic anion. There's only one positive polyatomic ion, that's ammonium, that you'll be talking about later. So how do we write formulas? You must know the charges. That's why you have that periodic table. And if you recall from, I believe, chapter 2, we learned about the ions from the periodic table. So group 1 always has a +1 charge. Group 2 always has a +2 charge. Group 15, starting with nitrogen, if it's a non-metal, has a 3 negative. Group 16, starting with oxygen, is a 2 negative. Your halogens are a 1 negative, and your noble gases have no charges. So make sure you know that. All right, so let's see what the notes say. Ionic compounds always have positive and negative charges. So number 2 is huge. If you can, I would, oh, it's going to be yellow today. Star this. In a chemical formula, the sum, what's a sum? Oh, that's when you add them up. Of the positive and negatives must equal the sum of the negative charges. All right, so the charges of the cations must equal the sum of the charges of the anions. I think I wrote sum twice. So also the formula of an ionic compound must reflect the smallest whole number ratio. So if you have something like this, PB2O4, something like that, that is not a small whole number ratio. So what would be the formula instead of PB2O4? What can you reduce these numbers as PB, oops, what's that? PBO2. Well, you can write that down. So here, I guess I can do it again. So this would be PB, no, try it one more time. PBO2. That's an O. All right, so you got the idea. Okay, so it has to reflect the small number whole number ratio. So I can divide each number by 2, so I get PB1O2. All right. Let's go on to the next page. So this is how to write the formula. You must know the charges of the cations and anions. That's a must. Number 2 is really important. If the charges cancel already without doing anything, there will be no subscripts. But if the charges do not cancel, then you're going to crisscross the charges for the subscripts, leaving the positive or the negative off the subscript. What is a subscript, by the way? A subscript is what's written below. So on your periodic table, find aluminum and what is its charge. So look it up. Did you get a +3? What is the charge of an oxygen? Did you get a -2? So do the charges cancel out? No. So what is it you're going to have to do? Well, we're going to crisscross. Are you ready? So we're going to criss and cross. So what do we get here? We put a 2 here. That's a 2. And a 3 here. I can't write very well with this pen, can I? So what's my formula? Al2O3. Okay, so what about the next one? Well, what's the charge of calcium? Look it up on your periodic table. What is its charge? Hopefully you got a 2+. Hey, oxygen again. Okay. Do the charges cancel out? Is the answer yes? Then what happens here? Nothing. There's no subscript. It's just CaO. Okay. So what's next? So naming, I think, is a lot easier than writing the formulas, okay? It says this depends on both the cation and the anion. Now, if the cation is from group 1, 2, or aluminum, zinc, cadmium, or silver, then it says Trout will add scandium to the list. I've never seen in any other textbook with scandium, so I'm going to go with not, all right, but just an FYI, Trout does this. They are what I call always, always. Group 1, So your sodium, your potassium will always be +1. Your group 2 will always be, obviously, +2. Aluminum is always 3+, okay? But what about zinc and cadmium? They both are going to be a 2+, and your silver is just 1+. I'll just put a little plus sign here. So zinc and cadmium are always 2+. Aluminum is always 3+, and silver is always +1, or just 1+. Those are, again, are what I call always, always, okay? If this is what we call a binary ionic compound, binary means two different. So if you have only one element as your cation and only one element as your anion, it's binary, and it's going to end in "ide." Okay, so let's take a look at this. Here I have a group 2, so it's a +2, and here's just bromine, nothing else, just bromine. So how do I name this? It's calcium bromide. So you drop the "ene" and put the "ide" at the end. So what about letter B over here? Silver is one of these guys, isn't it? It's always, always. So I don't need Roman numerals that we're going to do next. Nitrogen is all by itself. It's just nitrogen. So it becomes silver nitride. What about over here? Potassium is group 1, so it's an always, always. Oxygen is all by itself, just O, so it's binary. 2 different elements, that's it. So you just name it as potassium oxide. That's right, and an "ide." Zinc is an always, always. It's up here in this list. Know that, memorize that. So zinc is always, always 2+. Sulfur is all by itself, so it is zinc sulfide. Okay, now the fun begins. Let's check out the next section. All right, so the cation, if the cation, that's your positive. So if the metal has variable possible charges, that is every other element besides what you had to memorize. Group 1, group 2, aluminum, zinc, cadmium, and silver. Okay, every other element. Mrs. Vanderwalle calls these wishy-washy. All right, wishy-washy means it doesn't have to be one thing, it can be one thing or another thing, okay? So you name the cation, the wishy-washy cation, then you need Roman numerals in parentheses to tell you its charge, okay? And then again, if it's a binary, you add the anion plus "ide." So these are the rest of the metals. Again, I call them wishy-washy. So the charge of the metal must be determined by the anion it is paired with. So example, name PbCl4. So Pb is wishy-washy, it's lead. It's one of those Latin ones, so plum bum lead. This is a little shortcut to help you. So reverse the crisscross. What is the subscript of lead? There isn't one, it's 1. So is 1 the charge of chlorine, yes or no? Yes. If that's a yes, then 4, oops, go the opposite again, okay, go the opposite again. And so 4 is the charge of the lead. Will you stop that? So 4 is the charge of lead. One more time here. 4 is, there we go, 4 is the charge of lead. So because lead is paired with 4 chlorines, the total negative charge is -4, so your cation is +4. Therefore, it's called lead, Roman numeral 4, chloride. So what I have done is I have put the charges of your anions. These are your always, always. Every anion is an always, always. So let's go ahead and see what happens here. I'm going to do my little shortcut. So watch what happens. Is 1 the charge of oxygen? No, it is not. It is 2 negative. So therefore, you can't do the reverse crisscross. Do you see any subscripts? No, I don't. Why not? Well, why don't you see any subscripts? So what happened up here when you didn't have any subscripts? The charge is canceled. So that's the same thing down here. Because there are no subscripts, the charges canceled out. So what is the charge of oxide? It's 2 negative. So what must be the charge of copper? 2 plus. So you get copper, Roman numeral 2, oxide. Well, let's try the same thing over here now. Okay, here's letter B. So what is Mrs. Vandewalle's shortcut? Reverse the crisscross. So is 2 the charge of oxygen? Yes, it is. Therefore, the reverse crisscross works. How many oxygens have you in the formula? 1. So what must the charge of copper be? plus 1. And let's just stop for a minute and see what we have done. Remember what we said on the prior page, the sum of the charges must cancel out. So for the case of this one, the copper is a plus 2, the oxygen is a minus 2. Do the charges cancel out? And the answer is yes, they do. Over here, I have 2 coppers at a plus 1, right? That's what that Roman numeral tells me. Oops, I forgot the 1. There we go, at a plus 1. Does it and the negative 2 cancel out? And your answer is, well, 2 times 1 is positive 2. It cancels out the negative 2. So that's what we're actually doing. This is our purpose. This is our goal, is that the charges will cancel out. So if you do my little shortcut, you'll see that it works, all right? So let's try this one. Let's reverse the crisscross. Is negative 1 the charge of chlorine? Well, yes, it is. It's a halogen. So what does that mean? What's the charge of chromium? It's 3. So when we're done here, we're going to have, so the name is going to be chromium, Roman numeral 3, chloride. So once again, does this all work? So how many chromiums do you have? 1. What's its charge? Plus 3. How many chlorines do you have? 3. Each of them are negative 1 for a total negative 3 charge. Should the charges cancel out? Yes, they do. Let's check the next one. Is negative 1 the charge of fluorine? Yes, it is. Therefore, 1 must be the charge of gold. So I get gold 1 fluoride. Come here. There you go. Also, how else could you have done this? There are no subscripts. Therefore, the charges have already canceled. So whatever the charge of fluorine is the charge of gold. So let's see again how this works, all right? So let's go this direction. Is 1 the charge of nitrogen? No, it's not. It's 3 negative. So does that mean that the charges cancel? No, they don't. I mean, I'm sorry, I'll take that back again. So what's going on? So the 1 is not going to be the charge of iron. That's what I was trying to say. So do you notice any subscripts? No, I don't. So why not? The charges have already canceled. So if nitrogen is negative 3, then iron must be positive 3. Well, if you were clever, you've already seen that, didn't you? I didn't hide that very well, did I? All right, so why don't you do letter F, see what you get. All right, did you get this? Cobalt 2 sulfide. How did I know that? Go away. Are there any charges, or are there any subscripts in the COS? The answer is no, I don't see any. Why not? Because the charges have already canceled. So whatever the charge of sulfide is the charge of cobalt. Okay. So let's go on to the next page. You're going to like this one. So actually, I think I'm going to quit this blank wall now. This is a good breaking point. I'm not going to be able to finish this whole thing in 2 minutes. So I'll stop here, quickly go on to the next one, but I'll still end with the don't wait to be great. Bye, everyone.